Right now, 3 billion digital video streams are flowing across the internet. From TikTok dances to Twitch gaming sessions, this continuous torrent of pixels moves through global server arrays every single day. Suppose you're watching a standard, slightly grainy viral clip of a cat. Underneath that exact video, hidden completely from view, someone is transmitting an encrypted database directly to a journalist in a heavily monitored country. This chart breaks down the global streaming scale. With 100 million concurrent streams running at any given moment, the network already exists to host anywhere from 100,000 to 1 million invisible, real-time communication channels. True secrecy in the digital age relies on moving beyond simple encryption. It requires hiding the very existence of a communication channel inside the infinite noise of the modern internet. Modern software architecture forces a specific compromise. To communicate, you have to rely on centralized corporate gatekeepers, navigate App Store monitors, and trust third-party servers to host your data. Even tools built specifically for privacy, like VPNs or the Tor network, have a structural vulnerability. Using them broadcasts a visible signal to your internet service provider, announcing exactly which privacy software you have installed. Because these network connections are visible, they remain vulnerable to aggressive firewall blocks, to network surveillance, and corporate transaction fees. As long as the digital infrastructure is visible and centralized, your ability to communicate remains at the mercy of the corporations hosting the connection. To see how Steg Streams bypasses these choke points, we have to examine the raw data. If we zoom into a single frame of a digital video until a single pixel fills the screen, we find the core mechanism. Every pixel on your screen gets its color from a specific mathematical string of ones and zeros, known as an 8-bit value. This relies on least significant bit, or LSB, steganography. By altering only the rightmost bit of that sequence, you change the numerical value, but the visual color change is imperceptible. That invisible alteration carries your AES 256 encrypted data. When you multiply that single bit change across millions of pixels, flashing 30 times a second, the capacity adds up. A standard 1-minute video stream contains roughly 6.6 megabytes of hidden storage space. Steg Streams effectively converts every pixel of ordinary video into a functional storage layer distributed across the globe. The primary engineering challenge here is compression. Social media platforms aggressively re-encode uploaded videos to save space, a process that typically destroys fragile pixel-level data. To validate the technology, the team embedded a Costa Coffee voucher, including a QR code and metadata, into a standard image file using LSB steganography. They uploaded that image directly to Facebook, an environment that typically reduces file quality by 70%. When they downloaded the image back from the platform, the hidden voucher was extracted completely intact and ready to scan. This moves the concept out of the theoretical lab. Because the data survived Facebook's aggressive compression, the protocol is platform agnostic, ready to function across WhatsApp, Twitter, or standard email. Phase 1 proved the platform can hide static files like vouchers and text. Phase 2 focuses on the project's ultimate ambition, hiding active, executable code. This is the code bridge. It utilizes WebAssembly, or WASM, low-level code that runs at near-native speed in web browsers. By routing code into a secure WASM sandbox hidden beneath the video layer, the platform can execute logic loops entirely within the stream. This enables interactive media, live calculators, or smart contracts to execute within the noise of a stream, requiring zero central servers. Steg Streams effectively becomes a decentralized execution environment, running invisibly inside the infrastructure of tech giants. Privacy-first platforms are often throttled by traditional payment processors. Companies like Stripe or PayPal levy a 2.9% tax and require surveillance compliance that creates a permanent paper trail of user activity. To maintain independence, Steg Streams integrated its subscription tier with USDC. Because this stablecoin lives on the blockchain, users retain self-sovereign control of their wallets, allowing for instant settlements with 0% transaction fees. Bypassing both the App Store infrastructure and traditional financial processors establishes a business model that is structurally resistant to external interference. Look again at the global network of 100 million concurrent video streams happening at this exact second. Hundreds of thousands of invisible, uncensorable communication channels could be operating within those feeds right now, appearing to any observer as nothing more than ordinary video traffic. For a journalist protecting a source or a citizen bypassing a government surveillance firewall, this infrastructure provides an immediate, scalable lifeline. The most resilient digital freedom now exists inside the infinite noise of the open internet.